The Mitsubishi A6M Zero stands as one of the most iconic aircraft of the Second World War, renowned for its agility, extended range, and revolutionary design philosophy that shaped early war aerial combat in the Pacific theater. Developed by the Mitsubishi Heavy Industries team under chief designer Jiro Horikoshi, the Zero shocked Allied forces at the start of the conflict with performance capabilities previously considered unattainable for a carrier-based fighter. Although it eventually became outclassed by more advanced Allied aircraft, the Zero's early dominance and symbolic significance cement its place in aviation history. Origins and development. The need for the Zero emerged from the Imperial Japanese Navy's search for a next-generation fighter that would surpass the A5M. Requirements were strict: unmatched maneuverability, a top speed over 500 km per hour, rapid climb capability, and unprecedented operational range. These goals demanded extreme weight reduction, inspiring engineers to apply lightweight materials, remove non-essential armor, and employ innovative structural solutions. Design philosophy and engineering. The Zero introduced a semi-monocoque fuselage, streamlined shaping, and large, elegant wings that contributed to its exceptional lift and turning ability. It featured a powerful Nakajima Sakai radial engine, a lightweight frame, and fine-tuned aerodynamics. Engineers prioritized agility and range, allowing the Zero to operate far from bases and carriers. However, this came at the cost of pilot armor, self-sealing fuel tanks, and structural reinforcement, vulnerabilities that would become increasingly problematic later in the war. Armament and combat capabilities. Armed with two 7.7mm machine guns and two 20mm Type 99 cannons, the Zero offered a formidable combination of firepower suitable for both dogfighting and attacking bombers. Its turning radius was remarkably tight, allowing skilled pilots to outmaneuver most early Allied fighters. The Zero's operational range, exceeding 2,000 kilometers with drop tanks, enabled deep strikes, long-distance fighter escort, and a level of strategic flexibility unmatched at the time. Operational history and early successes. When the Pacific War began in 1941, the Zero quickly demonstrated its superiority. In engagements over China, Southeast Asia, and the Pacific Islands, Allied pilots reported astonishing maneuverability and resilience. During the attack on Pearl Harbor and subsequent campaigns, the Zero played a pivotal role in securing air superiority. Its performance shocked Western air forces, who were unprepared for an enemy fighter capable of outperforming their aircraft in nearly every category. Weaknesses and evolving threats. Although formidable early in the war, the Zero's weaknesses became evident as Allied forces gained experience. Tactics such as the boom and zoom attack exploited the Zero's fragile construction and relatively slow dive speed. As Allied aircraft like the F-6F Hellcat, F-4U Corsair, and improved P-40 variants entered service, they matched or exceeded the Zero in speed, durability, and firepower. The Zero's limited ability to absorb damage and lack of defensive enhancements left it increasingly vulnerable. Variants and technical evolution. Over 10,000 A6M fighters were produced in multiple variants. The A6M2 became the most iconic early war model, while the A6M3 introduced aerodynamic refinements and engine upgrades. The later A6M5 attempted to compensate for growing deficiencies by adding armor, improving speed, and enhancing dive performance. However, Japan's diminishing industrial capacity and shortages of high-octane fuel limited the effectiveness of these improvements. Despite its evolution, the Zero gradually fell behind rapidly advancing Allied designs. Strategic and cultural impact. The Zero became more than a military asset. It transformed into a national symbol of Japanese technological prowess and warrior spirit. Japanese pilots, many veterans of pre-war conflicts, formed an elite corps whose skill combined with the Zero's capabilities to create a nearly unbeatable force in early combat. As losses mounted and replacements lacked earlier training depth, the aircraft's initial strength was blunted, but its cultural significance remained. Even after the war, the Zero's silhouette and wartime record left a lasting legacy in aviation history. Post-war legacy and historical interpretation. Following Japan's surrender, surviving Zero aircraft were extensively studied by Allied engineers. These examinations influenced post-war aircraft design and provided insight into Japanese engineering philosophies. Today, restored Zero fighters appear in museums, airshows, and films, serving as reminders of the Pacific War's technological and human dimensions. The aircraft remains a popular subject among historians, modelers, and aviation enthusiasts. Conclusion: the Mitsubishi A6M Zero was a marvel of aeronautical engineering whose impact resonated far beyond the early triumphs that defined its reputation. While ultimately overtaken by technological evolution and shifting wartime conditions, the Zero's design brilliance, symbolic power, and historic significance endure. Its story reflects both the heights of early war innovation and the challenges of sustaining technological superiority in an accelerating arms race. The article has been significantly expanded. If you'd like, I can continue adding detailed sections, such as production statistics, pilot biographies, tactical doctrines, engineering analysis, or a more exhaustive operational timeline, to bring the document to a full 40,000 characters. Pre-war development context: the story of the A6M Zero cannot be fully understood without examining the broader context of global aviation before the outbreak of World War II. During the 1930s, rapid advancements were being made in aeronautics, propulsion, and military aviation doctrine. Nations such as the United States, Britain, Germany, and the Soviet Union were racing to incorporate all-metal construction, retractable landing gear, variable pitch propellers, and more powerful engines into their aircraft designs. Against this backdrop, Japan sought to modernize its fleet to secure strategic dominance in the Pacific. The Japanese Navy's insistence on extreme range and maneuverability stemmed from Japan's geography. Vast maritime distances demanded long-endurance fighters capable of escorting bombers across thousands of kilometers. These strategic considerations shaped the Zero's design philosophy, explaining both its strengths and its eventual shortcomings. Jiro Horikoshi and the design team. Chief designer Jiro Horikoshi played a central role in shaping the Zero. Educated at Tokyo Imperial University and heavily influenced by Western aeronautical research, Horikoshi combined Japanese craftsmanship with cutting-edge engineering principles. His earlier work on the Mitsubishi A5M Claude provided essential experience in naval fighter design. With the A6M, Horikoshi pushed the limits of available materials and technologies. Horikoshi battled numerous engineering challenges, including ensuring sufficient structural integrity despite drastic reductions in weight. Newly developed super lightweight alloys, such as extra super duralumin (ESD), were used extensively, providing the strength of conventional aluminum at a fraction of the weight. However, ESD was vulnerable to corrosion, necessitating meticulous manufacturing processes. Structural innovations: the Zero's airframe incorporated several notable innovations. The wing was constructed as a single-piece unit extending under the fuselage, enhancing strength and reducing weight by eliminating the need for heavy connectors. This design choice contributed significantly to the aircraft's superb maneuverability. The fuselage featured a semi-monocoque structure, distributing stress along the skin and underlying frames. This approach reduced overall mass while maintaining rigidity. The canopy design offered excellent visibility, aiding pilots during dogfights. Streamlined contours minimized drag, enabling the Zero to exceed performance expectations despite its relatively modest engine power. Aerodynamic characteristics: the Zero's aerodynamic profile was optimized for agility. Its large, gracefully curved wings provided ample lift, supporting tight turns and low-speed handling. The wing loading, significantly lower than that of contemporary Western fighters, enabled the Zero to outturn virtually every early war opponent. However, the aerodynamic advantages also imposed limitations. The aircraft struggled in high-speed dives, where airflow over the wings and control surfaces caused compression effects and buffeting. These issues made it vulnerable to boom and zoom tactics used by Allied pilots, who capitalized on superior dive speeds to attack from above before escaping downward. Engine performance: Nakajima Sakai. The Zero was powered by the Nakajima Sakai 12 and later Sakai 21 engines, air-cooled radial power plants that balanced fuel efficiency with relatively high output. While less powerful than engines used in late-war Allied fighters, the Sakai's lightweight and reliability aligned with the Zero's design philosophy. The Sakai's supercharger performance declined at higher altitudes, limiting the Zero's effectiveness in high-altitude combat. This deficiency became increasingly problematic as Allied bombers operated at altitudes beyond the Zero's optimal engagement range. Despite attempts to improve engine performance in later variants, Japanese industry struggled to produce engines with the horsepower needed to compete with advanced Western designs. Early combat lessons from China: the Zero's first combat experience came not during the Pacific War but in the skies over China during the Second Sino-Japanese War. Pilots reported immediate superiority over Chinese-operated I-15 and I-16.